All right. Welcome back to Teaching Elixir. Apparently that's what I'm calling this series, where me and a friend are helping my friend pick up some Elixir. And we are using Livebook to do it. So we've done basics, we've done collection, and now I was a bit surprised to see that we are getting into some real meat and potatoes here. We're doing the Enum module. Apologies for my voice. I celebrate my birthday this weekend, and it's a bit hoarse. And my friend is also here. Hello.
Hello.
And we might encounter some errors in this file because I did some terrible searching and replacing before we started to try to change the original Elixir School format to Livebook. And I see that this does not look right, so let's do that. So if we do some weird correcting here and there, it's nothing that you need to be particularly worried about. It's just that I did something lazy and sloppy and didn't notice all the errors. Okay, so enums. So there's something you know what they are.
Isn't that the module in Ruby which contains all the good stuff?
Probably. I don't know Ruby, so
because an enum for me is an
enumeration.
Yeah. So it's like a
it's a bunch of named values, right?
Yeah. A tagged union usually.
Okay. Yeah. So it would be stuff like if you have a status enum, it could be draft, published, archived, something like that. This is not that. This is enumerables.
Okay, so everything you can enumerate.
Yeah, so lists and maps and strings and stuff. So
this leads to the question: Can we enumerate the content of the Enum module? Huh, we could. Nice.
Yeah.
Wow. Yeah.
So that's the first lesson. We will enumerate the Enum module, and that's nice. There's actually a nice piece about introspection here. Just module. Each Elixir module provides an info functions function. I don't know if that's an Erlang thing or if it's an Elixir thing. I wouldn't be surprised if it's an Erlang thing.
Yeah.
So then we can just enumerate that and print all of these, and we will get into sort of each and how that works as we go.
So, so the info function, can it return or evaluate to a value or an error, or why do we have the exciting right arrow?
So that's the pipe operator in Elixir. So if we remove that and reevaluate this, it gives us a list of key and arity.
Cool. Okay, so the pipe operator is basically function application, but the other way around. you give the arguments to the left, and
it will pipe the output of the previous statement into as the first argument of the next.
Okay, so that's the everything, of course. Yeah, good. Okay, got it.
All right, so the Enum module also has a sibling called the stream module, which can do, let's say, similar things to similar data structures, but does that in a lazy way, which is incredibly useful for some things, but it doesn't allow as many operations.
Yep.
And anything enumerable is something that, like an enumerable is something that you can step through piece by piece, essentially. And if I'm not mistaken, enumerability is defined in Elixir by implementing a protocol. Yeah, it implements the enumerable protocol. So you can actually create your own enumerables by defining an implementation of that protocol. And then you can enumerate with certain operations. You can say, I want to enumerate this into this thing, and then you might want a collectible protocol.
Yes.
But by default, pretty much most enumerable operations that aren't reductive in some way tend to output a list.
Yep.
All right. All question mark. So this is an interesting convention in Elixir. Booleans question mark. So anytime the output will be a Boolean, it's good form to use a question mark.
Okay, cool. Another Ruby is nice.
Quite possible. There's also an exclamation point, but that's not gonna be used in this module. The exclamation point will means that this can throw an error rather than return an OK error tuple. And these are just conventions. I mean, they're not enforced in the system as such. But
yeah.
Did we have an error in our one of these?
Not at all.
No.
I just wanted it to be true. It said foo bar hello, and if all of them had the length 3, it would give true, and they don't. So I fixed that.
Yeah. Actually, this one is supposed to be from the examples more than 1. So we can actually give varied. You're jumping ahead. No mapping. There will be no mapping yet. All right. So all will apply a function to every item of the list or the enumerable. And if every one of them checks out to be true, so if every function application evaluates to true, the entire enum all call will enumerate and will return true. And then we have the next one, any, which is sort of the opposite. If any of them return true, it will all return true. So that one probably short circuits as well. I would expect it to.
Hopefully.
I haven't checked the implementation, but I expect it to. These seem fairly straightforward to you, I imagine.
Yep. I've seen them in, I think, Python first time with the same names. Yep.
I don't recall them being in Python, but it might be parts of the language I haven't used much.
They are among the built-in functions.
Yeah.
Very good stuff.
Now I'm being silly and just removing the parentheses around the S because that's not necessary syntax.
It's interesting. Now it looks... but it's necessary when you call a function.
Yes.
So you
or that depends.
Oh, you can do that, and suddenly the code looks like Haskell. Very nice.
Yeah, you can also just do that.
Yeah, of course, because...
Oh, the Livebook is doing something fun now. Okay, yeah, it might have problems with precedence right now. But yes.
In theory, you could have done.
So, single argument functions at the very least allow you to skip the parentheses, and I think you can actually do it for others as well. But the convention is to use parentheses.
Yep.
Mostly. Except when you're doing DSL style things. All right. Chunk every. If you need to break your collection up into smaller groups, chunk every 2 is the function you're looking for. It chunks it. So it turns this list of 6 items into a list of 2-item sections.
Yeah. This is one of those functions I always need and always have to write myself. So it's very good that it's in Elixir.
Okay.
Ha! Legendary. Yes.
What did you do?
Yeah. I remove a parenthesis. Cool.
Be nice. All right, chunk by. So then you can do dynamic chunking.
Good stuff. Yeah.
So based on a function, so in this case, you can chunk them on string length.
Yep.
And chunk by takes a given enumerable and a function, and when the return of that function changes, a new group is started. Okay.
Was that any difference? Yep. Huh. Ah, cool. Yep. Good stuff. So we can give it basically any function and it will be fine. Or, yeah.
Yeah, it's already wrapped in. So this is the function we're giving it. So this is the lambda anonymous function thing,
Yeah.
where it takes 1 arg and that's x.
Okay, I'm gonna do some more syntax exploration. Boo. So this wasn't possible. Can I write : or something?
So we will actually get to what you're trying to do, but the actual syntax you're looking for is this.
Huh.
So
Wow.
this is passing a function by reference, essentially, saying I want to send this function as an argument.
Yeah, it's a mouthful, but I can see why it's useful to have a specific syntax for it.
So since you need to specify the arity, you will need to specify the arity. And then there's the and sign means, we're not calling this function, we're just passing it.
Yeah.
There's also a little bit of annoying syntax around calling a function that is passed as a reference. So when you're doing a callback or whatever, I'm not super fan of how that works.
Okay.
It's fine, but it's map every. Sometimes chunking out a collection isn't enough for exactly what we may need. If this is the case, map every can be very useful to hit every nth items, always hitting the first one.
Every 3 items. Huh. Okay.
So we haven't gone through what a map function does.
I wonder. Yeah, but it's soon, so it's cool.
Yeah. So this allows you to, for example, if you need to odd even something, this would work. But also for other numbers than 1, 2. All right. But then each. So this is when it's necessary to iterate over a collection without producing a new value. For this case, we use each. So this is essentially when all you care about is side effects.
Yep.
Which it sometimes feels like this should be a crime, but I mean, it's better than accidentally modifying the return value.
Yeah. And it's very useful.
Yeah, so if you need to log something about everything in an item, or write every piece to a file, or send a number of requests based on a list, that's when you would typically use this. So
And
in this case, they use IO puts, which is, of course, a side effect. So that's
indeed. And we get the colon OK because everything went well. Does each give the colon OK? And what happens if one fails?
Each is giving the colon OK, and I mean fails in what way? Like if it would throw an error, the entire each call would have an error. It would. If an error was raised, it would bubble past the each.
Yeah. So
unless we try catching. So.
Yeah. Let's say we have some connection somewhere. We want to send some data, and the first one passes, the second one fails. What will happen then?
Fails in what way?
Anyway, doesn't matter. But
if it throws, this would break. So this doesn't capture any kind of error like that, or but if it just returned an error tuple, nothing specific would happen unless you're matching on that error tuple to be an OK tuple. So if you're matching that the return value would be OK, then this would do a match error, of course.
Cool. Got it.
Yeah, and just for context, when we're talking about side effects, this is functional programming talk for it does something that isn't receiving input and producing output. Like it isn't taking an argument and producing a return value. It's doing something else. It's talking to a database or dealing with like reading the system clock, for example. That's pulling in data from side effect land. And if you're writing or outputting data into something other than the return value, you are in side effect land. It's an impure function.
Yep.
And they are generally what does all the useful work in software, but they're also where all the errors happen.
Yep.
Or most of the errors happen. All right. Map. Now I would say this one is important of everything we've covered here. I think I've used any and all quite a lot, and most of the other ones not so much. Each I use fairly frequently, but I could just as well use map in many cases.
Cool. I haven't seen any loops in Elixir so far.
It does have one.
It does have one.
But it's, a functional loop is very, very map.
Yeah.
So there's a four keyword, or I think it's just honestly a macro.
Okay.
And it's essentially mappy, reducey kind of thing. Like if you use a for loop straight in Elixir, it essentially gives you what Enum map does. And if you add, for example, into and then say I want it into the map syntax, then you will get a map at the end, which means it's doing enum map and then enum into map or in map new or something. So, and you can add filtering and a bunch of stuff. So the for syntax is like, if you actually look at the feature set of the for loop in Elixir, it's humongous. But I rarely use for loops, and I use them very sparingly because I find you can make things a lot clearer with a pipeline of enum operations.
Yep.
All right. So map, it takes an incoming list in this example, but enumerable, and it applies a function to it, and the result of the entire map operation is the list of each item after function application.
Yep.
And this is outputted as a list regardless of what it was coming in. So we can actually add an example here, which is just map foo1 bar 2 fn x and so now we're not doing anything to that one. Fn is I need
More
a comma.
Commas.
You can see it returns a weirdo list, which is it's a keyword list. So it took our map and turned it into a keyword list. Why? Because when you're enumerating a map, you get both the key and the value, and you get them as a tuple.
Cool. Okay,
so if we want to do something weird with this, we could do foo key value, and we'll stop seeing the keyword argument syntax or keyword list syntax, because we're no longer producing a proper keyword list. We're always adding foo, and it's a thruple, not a tuple.
Yep.
But yeah, you end up doing this type of thing a lot.
Yeah.
Because keys and values, they're important.
Good stuff.
Yeah. Let's see, is there anything else? You could, of course, pass it a keyword list as well. Or
yep.
We'll get to more examples, I think, of what's actually enumerable further down. But this one is very important. So something to imagine, for example, if you're reading data from a JSON API and you're getting a list of, let's say, a list of your repositories from GitHub, for example.
Yep.
That has a certain format, and you probably don't want most of the information. So you might want to remove, adapt it to some kind of map format that you actually have, or just call some function on it that removes a bunch of cruft.
Yep.
And map would be helpful for that. So then you would just call a function on each of the items, because you want each of the items, but you don't want the current format of them.
Nice.
Min. That was fairly straightforward. It finds the minimal value in the collection.
A min2 lets us produce a minimal value. Okay, so what happens?
In the case if the enumerable is empty, it allows us to specify a function to produce the minimum value.
Okay. So we get an empty error if it isn't provided.
And max.
And same thing.
And max too.
Yeah.
So, yeah. These
Nothing
are
strange
all
there.
good and useful. Filter. This is a good one. Let's imagine that GitHub repo example. If you wanted to filter out every repo that is tagged as archived, for example,
Yep.
from that list, you would probably use this. Then you could just check for, in this fnx here, you would just go x archived equals true, then, or if x archived is false, sweet, then we can keep it.
Yep.
Essentially. So this will return only those items of the list that return true. It has a sibling, which I don't think is mentioned here.
Oh, so
you
filter.
don't actually have to invert the logic in the function. You can just use enum reject, which I think is nice.
Yep.
It just means you have to read it a little bit more carefully on that end. But it makes the, for example, pipelines look better.
Yep.
Reduce. Now this one, it takes a bit of work to get used to. I think you probably know what a reduce is and what it does.
It's so if we it will apply the function we give it to every element, to every pair of the first value and the accumulator.
Yeah.
That's all there is to it, really. There's something with it that is really brain bending, but I can't remember what.
So, yeah, reducers or reduce calls. I found them super confusing for a while, and I think what helped me the most is recognizing that the two ones to care the most about is map and reduce.
Yep.
And map will always return a list of the same size, so it will never change the shape of the data, of the outer part of the data at least.
It might change the type of it.
Yeah, but it will not change the size of the enumerable.
Exactly.
So whenever you need to turn something from, for example, a list and into a map, you will end up using some kind of reduce. There are enum.into, which can shove things into a map, but if what you're working with is something more complex, or if you need to do multiple operations at once. So if you need to take one item and figure out, maybe this should be in the output, maybe it shouldn't, but it also needs to be modified.
Yeah. And
sometimes there are good reasons not to do these in sequence, but rather do them all at once. Especially if each would invoke sort of a network call or whatever.
Yep.
Then that's also usually what you would use reduce for. So the reduce function takes, usually you pass in an accumulator. In this case they pass in 10, and that's this is a return value in its initial form. This is the value we will be working with aside from the enumerable. So when we get into our first invocation of fn, our reducer function, we will get the first item of the enumerable, and we will get this 10 that we entered. This is our accumulator. And in this case, we take the value from the enumerable and we add it to the accumulator. We're accumulating. So this starts at 10 and then sums, essentially. Or rather, no, it doesn't. Yeah. I guess it does sum it.
I think you could write this as...
Yeah. So if you start at 0, this would be 6.
Yeah.
So this enum sum exists, I believe. But each function invocation returns the updated accumulator.
They are the same, right?
Yeah.
Enum reduce and enum sum. So sum is reducer in its form.
Yeah, it would be.
Yeah.
So any and all are also sort of the shape of a reducer, because there's also reduce while, I think it's called, which is a reduce function where you can provide a short circuit, so you can say, okay, we're done. Stop enumerating. We know that, so you can do an early return, essentially.
Cool.
And then that operates from you passing an atom, either cont or complete or done or success or whatever it is.
Yep.
But yeah, if you have a bunch of conditional behavior you want in while processing your your list, sort of maybe you have a case statement or something you want to add in, or an if statement. It's very common that what you're needing is a reduce, especially if that determines whether it should be added in the output. So here we have an example where it's enumerating a list of strings, and then it's concatenating them together.
Yep.
Which is also a way of building something. Okay.
Very nice.
Getting fancy.
Now we made a palindrome.
Sorting. So it can sort numbers. Whoa! It can also sort anything.
Yeah, and the term ordering we saw in the first lesson, I think.
Yeah, and Erlang term ordering it's sometimes a little bit odd, but it's very useful.
And it's defined somewhere.
Yeah,
deterministic, and
that's the important part. It is defined. And then we have sort to, which allows us to provide our own sorting function, which can sometimes be a syntax error.
Oh, okay.
Yeah, I think this is missing.
Yeah, you're missing a couple of L's.
Yeah, I'll just find the original lesson. This is one of the find and replace screw ups for sure. Let's see. We were at sort, right? That one. That should be that one. Let's just go. Boo.
Good stuff.
Yeah.
Let me add another one and see what happens. Okay, so what's the idea behind this? Okay, that's the syntax. Okay, that's what it checks. Good.
Yeah.
So it sorts them in opposite order.
Yeah. There's a few other sorty enum functions as well, sort by and stuff.
Yep.
So there's a bunch of ways to do this. This one also allows you to pass in descending or ascending. Oh, I accidentally opened a terminal.
Nice.
Not even sure how I did it. I think there are mouse shortcuts for opening a terminal.
What? Why?
Now I gotta check. Is that... No? I don't know what I did. Alright. And then there's unique, which would be a reducer as well.
Yep.
So that I can remove anything that's not unique, which is nice. Quite useful.
Indeed.
Unique by, but it allows us to provide a function to do the uniqueness comparison. So if you have these repos where we were talking about, or maybe more typically, let's say we have a bunch of repos in maps that come from a bunch of different creators. So maybe it's an org, like a GitHub organization.
Yep.
And you want to include one repo per author or per creator or originator. You could do unique by and sort of who created the repo, and then you would have one per person. So if you're fetching data which may contain duplicates, and you have a same key value situation to check, so you can check an ID or whatever, unique by is pretty helpful there.
Cool.
enum using the capture operator. Yeah, okay, so this, we actually did play around with this earlier. So below is typical example of the standard syntax when passing an anonymous function to enum map. Like this is what we've been doing.
Yep.
And this, God, I don't like this syntax. It's not a bad syntax, I just don't find it very readable. Or maybe it is a bad syntax because I don't find it very readable. But I always tend to expand. Unless there's a very good reason, I tend to expand this syntax into the above FN syntax because I find this too dense to parse usefully.
Yeah, I get serious regular expression vibes.
Yeah, but let's unpack it. Like this is your FN.
Yep.
And it implies that like there will be args. But we're not specifying the args, and instead of the number we're saying and 1, so the first argument will be used.
Got it.
And this syntax just creates a function just like the FN syntax. So here we see an example where they are actually binding it to a variable.
Cool.
And if we want to just call this function, this is an anonymous function call.
And then you need the dot.
Yes, you need the dot.
For some reason.
It makes it explicit that it is a bound function and that you're not trying to call sort of an existing function.
Oh, okay.
Either in this module or that's imported in this module or whatever.
Yep.
Or one of the built-ins.
Yeah.
Using the capture operator with a named function. So here they define an actual module, def module adding,
yep,
def plus 3. And here we see that, yeah, it can be used inside an anonymous function, great. But it can also be referenced in that way.
Yep.
But actually, when you're doing this, you don't need to do that because the plus 3 function only takes one arg. So you can just reference it directly by the name and the arity and say, okay, we want the one that takes one arg, please. Thank you.
Got it.
So that's enumerables. Questions?
Very nice. Nah, they seem useful.
Yeah, they're pretty useful. Something I want to add, which isn't covered here, and I think it's fine that it's not covered here. It's just how I typically use an enumerable. So let's do. So if we have this type of data. And let's say it can be archived, true, archived, false, archived, false. All right, so that's the list. Yep. And maybe we want to enum.filter that.
Yep.
So now we're piping this into the filter operator, and then we're having a function, and we will get our repo, and then we will say, okay, filter repo. Actually, let's not use filter. Let's use reject because I want.
Yeah.
So if it's archived, repo.archived, bam. This should mean syntax error. That's what it should mean. Okay. I'm a little bit surprised.
Unexpected token $. Yeah, you have a dollar sign instead.
Dollar. There we go.
Very nice.
All right, so then we remove those, and then we want to make sure that this is a different shape. I mean, we don't need that archived info anymore. So we go repo.repo to get the name. And then maybe we want it into a specific type of function or a specific type of structure.
Yep.
That contains like it should be a map with the type repos, and then we just have this name. Maybe it should have a list of repos. This is a little bit convoluted, but hey, then I just call it ACK, and then just map put ACK repos, and this would be like, oh right, name ACK.repos.
Yep.
So now I'm prefixing those, and now I did something bad. Yeah, I did not do this right. So to the repos key there.
There we go. Nice.
Yeah. Or if we actually just want to turn these into a new map based on this, we could take the repo name and we could take, since we don't have any other values, let's do repo archive. Okay, so now we have a list of tuples.
Yep.
And then we could do enum into,
cool.
or we could also do map.new.
Yep.
That's the same. Potentially a little bit different performance, but it's essentially the same. Yeah, so these these pipelines are neat. I find them, they usually end up very readable, which is nice.
Yeah.
So yeah, I will remove this part just because I want, in case Elixir School ever has a use for our live books, I try to keep them clean.
Yep.
But okay, that was enums. Nice. I wonder what's next, actually. So next time would be pattern matching.
The good stuff.
That's definitely one of them.
Yep.
All right, that's it for now. Thanks for watching.